Greetings, everyone. My name is Lucas Dusablin, and I am with Clean Fuels Ohio. It's my pleasure to bring to you the May webinar of the Ohio NGV Partnership webinar series. This one is going to be on CNG station monitoring requirements. We will go ahead and take questions at the end of the presentation, so if you have any questions, please type them into the little question box that you have on your panel here, and we will go through those at the end of the presentation. And without any further ado, it's my pleasure to introduce Mr. Corey Miller from Sierra Monitor Corporation, who has put together a great presentation for you all, and I hope you enjoy. Go ahead and transfer the presenter mode over to him, and we'll be on our way.
Good morning, everyone, and thank you again, Lucas, and thank you very much to the Clean Fuels Ohio group. Let me make sure I get the proper screen showing here. And I hope that you folks are seeing the presentation at this point. Lucas, is that correct?
Correct. You look good.
All right. Thank you again, and good afternoon. Again, I can't thank Lucas enough and Clean Fuels Ohio. We're going to spend the next several minutes going through what we suggest it would take to prepare your maintenance facility to handle alternative fuel vehicles. As I said, the next few minutes will provide an insight to promote discussion on what will take to prepare the maintenance facility for alternative fuels. We begin defining some alternative fuels as non-diesel or gasoline that includes both the CNG, LNG, LPG, hydrogen, and fuel cell type vehicles. And then finally review hazardous nature of these fuels. We will also discuss the various codes and ordinances that influence the design of these systems. We will look at the equipment commonly used in the operations of these systems, both all the detection or alarming and mitigation, and then we'll look at the cost of ownership of these systems. The first fuel that we'll look at will be natural gas, chemical name CH4. Its explosive level is 5% by volume, meaning about 50,000 parts per million. That is 100% LEL. As a gas, it's lighter than normal air. It is odorless, and we see it in two forms. We see it both as compressed natural gas from about 3,600 to 4,000 psi, and we see a liquefied natural gas, which is cryogenic. They bring it down to a minus 260 degrees Fahrenheit. Hydrogen, on the other hand, has a 4% by volume. It is also much lighter than air. It is odorless, and it's used in two methods as fuel. First, it's as a combustion in engines, and finally it's used in the fuel cell to create electricity for an electric car. Propane, a very common fuel, is a 2.1% by volume. It's actually heavier than air, meaning that it would be close to the ground as a fume. It is also odorless and liquefied for storage and transportation, but gas for combustion. So they'll liquefy it and provide it as a fuel. Let's take a look at some of the codes that we'll reflect upon. The first one that we run into is from the International Code Council, would be the International Fire Code. The latest one is IFC 2012. The specific section that handles the regulations for lighter than air fuels is section 20 through 11, 7.2. It requires the gas extraction equipment be used for non-odorous gases, and it requires that these devices will be a performance-approved device. You'll also find this reflected in the International Mechanical Code as well as the International Building Code. Additional codes from the National Fire Protection Agency, NFPA for short, include NFPA 30A, a motor fuel dispensing facility and repair garages. This one was originally defined as NFPA 88B as in boy, was then rewritten and drafted as NFPA 30A. It goes to define the upper 18 inches of the ceiling of your facility for lighter than air fuels is now Class 1 Div 2. This will become very important in the considerations of design later in this presentation. NFPA 52 is the vehicular gas fuel systems, and it's probably one of the major standards used by the engineers for the design of a system. You'll find within NFPA 52 it strongly recommends that the engineers be familiar with this type of gaseous design and brought into the design itself. NFPA 88A defines parking structures for lighter-than-air fuel vehicles. And then finally, NFPA 59 is a standard for the storage and handling of LPG, or liquefied petroleum gases. Note that the International Code Series, NFPA 38, 52, and 88, are codes that are adopted or have been adopted voluntarily by the state or local authority having jurisdiction. This is very important because some local authorities may have adopted earlier versions and have not migrated to the new versions. Subsequently, you need to work with your local authority having jurisdiction to find out what codes they're presently working under and what they would prefer to use. Design considerations. First, when you begin to look at your facility, several of the key elements that you want to look at is the type of work that's being conducted on the vehicles. Is it major, removal of engine, or is it minor, the removal or replacement of tires? This can affect what type of code applications should be done and also reflect what type of designs may be necessary. We always strongly recommend that we solicit the services of a qualified engineer in the design portion. This is also defined in NFPA 52. Take a look at your building structure. Does your building have a flat roof? Does your building have a peaked roof? If it's a peaked roof, you might be able to reduce the amount of sensors to the center. Are the bays actually separated? Are the bays themselves open to each other? Are there pits for working in? These all have reflections of what type of gas detection requirements you'll have to do, as well as what type of mitigation. Is your building naturally ventilated? Is there big major doors on both sides to allow air to pass through? Are they canopied or the doors sealed? What are the surrounding buildings that will be affected by the operations in your stuff? What other considerations do you need to take a look at? In the occupied areas of your building, it can be sometimes beneficial to pressurize those particular areas so that you don't have to have gas detection in, so none of the natural gases or other fuels can migrate into those areas. Also identify where the ignition sources could be: heaters, grinders, welding areas. Can these be consolidated into one area and then cordoned off? These are the types of things. If there's a heater in there, you want to keep in mind that the heater can't have an open flame, the result of which could cause an explosion, so you may have to change your heater out. In addition, you want to make sure where you are graphically or climate considerations. I always look at this particular point as important, because if you're in the north and you have so many changes of air per hour that will allow you to not have a gas detection system, the cost of utilities may be high as a result of trying to heat that air in the summertime. Now, gas detection. There are two types of gas detection that we work with, basically the portable and the fixed. Portable is used as personal protection devices and are not used to detect methods in maintenance facilities. Fixed, on the other hand, are used to install with fewer wires, have third-party approval for complete systems, and simpler calibration techniques. The con is they're size limited. As little as 32, or as many as 32 sensors, or as little as 2 or 3. A sensor-based system has the pros of being more flexible in system design. It typically has third-party approval for the sensors only. It requires data wire and power wire, and calibrations can be a little bit cumbersome, requiring you to go to the sensor. In the case of, as you'll see further in this presentation, what I mean by that is that you may have to go to the sensor itself to actually do the calibration, as opposed to doing the calibration from the controller. Finally, OpenPath, a newer technology for our maintenance facilities, has been introduced. It's a less cost per area. It has fewer components. The problem with it is that it doesn't identify a specific area from where the gas is released, and it works in LEL meters. It's a little difficult to install because aiming is required, and if it's not on a stable surface, it'll have some issues with aiming being retained. And it's not always accepted by the local authority having jurisdiction. Let's take a look at the sensor technologies. There are three typical technologies that we use within a maintenance facility. The first two types are combustible, listed as catalytic bead or infrared. And finally, the electrochemical, which deals with our toxic gases, such as CO or NO2. The catalytic bead technology has been around for quite some time. It's used to measure both methane and hydrogen. Most sensors are performance approved by an NRTL or nationally recognized test laboratory. Those standards by which you should look for are UL 2075 or FM 6320 or CSA 22.2 number 152. Typically, a catalytic bead sensor requires periodic calibration, either 90 days or 180 days, depending on manufacturer. Infrared technology, a newer technology, is designed specifically for CH4 or methane. We rarely see it ever used with any of the other types of gases except perhaps propane. Hydrocarbons, it will not be used in a hydrogen application. The sensors themselves, both catalytic bead and infrared, will be located within 18 inches of the ceiling, providing first indication of a gas buildup of a lighter than air fuel. All sensors should be performance approved. Infrared is a very accurate and stable measurement device. It has a large measurement range, meaning that it can read from 0 to 100% by volume. It has a very low maintenance, and the calibration interval for this type of technology is generally 1 year. The electrochemical sensor, the one that I mentioned used for toxics, would be used typically for CO or NO2 in our facilities. It's located in the breathe zone between 4 foot and 7 foot off grade. It's current generating electrolytic reaction. It's highly sensitive to ppm parts per million levels of toxic gases, and it's very specific to the gases it's designed for. Here we take a look at a particular bus storage facility. In this particular case, if you look in the center of the picture, I'll try to identify there's a sensor located right here. This is an infrared type technology. There's an additional one here. I want to give you some idea of what it looks like to install or when these things are mounted. Here's a closer look at the sensors. You can see that it goes up from a junction box up into the 18-inch environment using rigid technology with a seal-off, and it's pointed down with the sensor faced out. This would be very typical installation for both the catalytic bead and infrared technologies. Here we see a typical CO application. If you look to the right, you'll see a sensor mounted on the wall. This sensor is a CO technology, electrochemical type sensor. Here's a closer view of this sensor. This sensor is mounted about 6 feet up from the wall, and it's pointed down to identify CO. Typical range for this type of device is between 0 and 500 parts per million. Now here we see a combustible type technology used in an LNG facility. You'll notice the sensor is located off the floor. The engineer's requirement here was that LNG could cool before it would actually expand to a gas and go to the ceiling. They wanted to indicate if there was gas as quickly as possible. So they had the sensor mounted at about 18 inches from the floor. Here we see a sensor mounted in the pit. This is an infrared sensor, again for an LNG facility. You see this duct here is also the mitigation. We'll talk about that in just a minute. But you can see the sensor is now mounted. This is actually required as a part of the code that these be mounted in these pit areas during an LNG application. Let's talk about now alarm and notification. Notification is required by code at 25% of the low explosive level of combustible. They have to be visual from all points within the facility. They need to be audible to everyone in the facility. They also need to be designed and commissioned as an ADA compliant alarm system. They need to be first responder initiative. They allow the authority having jurisdiction to know when it's safe to return. And I'll go through that in detail in just a minute. It then indicates for evacuation if required by the local code. Audible and visuals are different than fire alarm. This is very important. We'll talk about that as well. And auto dialers may be required. So let's take a look at some of these alarms that I talked about. Now here's one located in a maintenance facility that has an array of lights. The green light is obviously the light we'd all like to see. It means that the area is safe. Next to that is an amber light. The amber light in this case comes on at 20% of the low explosive level, and the horn evacuates the building. If the level of the gases continue to rise and it gets above 40%, it'll shunt non-essential electronic power, such as welders and grinders. It will then make sure the mitigation is in full operation and will latch as the red light. If the mitigation systems, exhaust and makeup airs, eliminate the gas, the green light will come back on, meaning the level has now dropped back to a safe level, but the red light will stay on, indicating that it's latched, continue to keep the mitigation going, and horns and remain the building. The first responders then will know that the area is now safe to go in, to check for the leakage, and to clear the system for the return of the occupants. Here's an outside version of the same array. This version does the same thing for the responders. They'll take a look at it. If it's green and red, they'll return to the building as safe. One of the things we're seeing more common now is that inside the building, since we're evacuating the building at a lower level than high, we'll see just it's a white alarm with blue. Note that it does not have the word fire on it, although located next to a fire alarm alarm horn and strobe, it has its own horn and strobe colors to indicate that there is a gas emission. And this typically goes off at 20 to 25% LEL. Now let's talk about mitigating, the real way to get rid of the gases. So after you've detected the gases, now you kick your fans on. If you have a natural airflow, you begin to utilize that as much as possible. You could pressurize the areas, as I mentioned earlier, in the offices to prevent any type of gas mitigating into those areas. You can evacuate the area using exhaust fans. You can use makeup air, such as the fans themselves or an HVA system to provide fresh air. Now I'm going to repeat that because it's extremely important. Ventilation is the primary key for evacuating the hazardous gases, both whether they're combustible or toxic. So in the case of ventilation, you want to use exhaust fans to get that gas out of there. You want to use makeup air, such as garage doors, vents, and air handling units to get fresh air in. You want to shut down any non-essential power, including grinders, welders, that type. And you want to make sure you comply to the explosion-proof requirements as outlined by the local authority having jurisdiction. Let's take a look at some examples of where the mitigation mechanics are involved. Here's a ventilation that actually exhaust fan. This is in an LNG facility, so it's located all the way down to the floor. This might be located in the ceiling area in the case of CNG. And here it complies to a single exhaust fan located on the roof. Combining them all together, we have a detection, a mitigation, and an evacuation. So the first thing we have is a detection. Then we have the mitigation with the fresh air and the exhaust. And then we have the alarming or the evacuation of the area through the controller. So let's take a look at a complete cost of ownership. Let's take the total cost of ownership. That is the utility cost that I talked about if you're running your airs at 4 to 6 changes per hour, which is required by the code, and then trying to heat it at the same time. Conversely, you can put a gas detection system in, and you can reduce that back down to normal unless the case of a detection. But in the cost of ownership, some of the things that generally get overlooked will be like the cost of maintaining the system. I use this picture to remind myself not only does the controller and the sensors need to be calibrated as periodically required, but you've also got batteries and a charge system that needs to be checked periodically. as well as testing the horns and strobes. One of the things that I talk with engineers about all the time is that these are a life safety system. It is absolutely imperative that we spend the time necessary to go through these periodically and make sure that the occupants understand what to happen in an emergency. Some of these guys some of the engineers I work with, we write actual SOPs or standard operating procedures for a biannual or annual fire alarm test, if you will, or gas alarm test more appropriately. These are the types of things that need to be considered in the cost of ownership. This is a life safety system designed to protect you in the event of an excursion of gases. Finally, let's take a look at a particular application. This one happens to be the Central Ohio Transit Authority, or COTA. The challenge for COTA was to reduce exhaust emissions and operating costs by switching the bus fleet to CNG. It was a $76 million renovation that was conducted last year. The solution, we installed an extensive experience in equipment design and proved the alternative fuel application. We provided an integrated system that detected, alarmed, and provided signals to mitigate those hazardous gas conditions. It's a very comprehensive system designed quick installation and fast approval by the local authority having jurisdiction. Are there any questions? And I turn it back over to Lucas.
Great. Thank you so much, Corey. Really appreciate it. Now, I don't have any questions at the moment, but if you guys, I'll go ahead and wait. If anyone in the group has any questions, go ahead and type it into the box, and I'll wait a moment. And just so everyone in the group knows, this webinar has been recorded and will be available on the Clean Fuels Ohio website for future viewings in the near future. Oh, thank you very much, Mike. You got a nice job, Corey. Mike wanted to say nice job.
Thank you.
Great. Well, since it looks like there aren't any other questions, I'll go ahead and wrap things up. Here, let me go ahead and flash Corey's information here one more time, just so you can all have it in case you have any questions. Thanks again, Corey, for presenting, and stay tuned for more information for our June webinar.
Thank you, Lucas, very much.
All right, great. Thanks a lot, everyone. Have a great day.